The sun rises in the east, the moon rises in the east, and the stars rise in the east. But solar eclipses oddly come from the west, like the April 2024 North American eclipse or the August 2027 North African eclipse. Except not all total eclipses come from the west. A few near the north and south poles actually head west for a bit before turning around and then heading east, which seems weird. If eclipses are caused by the sun and the moon, why don't they behave like the sun and the moon? The key to the explanation is that the paths of the sun and moon through the sky depend on the rotational speed of the objects involved, while the paths of eclipses depend on just the plain old straight line speed of the moon above the Earth's surface. Viewed from the North Pole, the Earth and moon both rotate counterclockwise, that is, towards the east. The path of the moon through the sky is determined by the line of sight from the Earth's surface to the moon, and because the Earth is rotating faster than the moon is orbiting, the sight line, and the moon, starts off pointing to the east at moonrise, then as the Earth rotates, the moon appears to pass overhead and set in the west, even though the moon is traveling towards the east the whole time. In contrast, the path of an eclipse is determined not by the direction from us to the moon, but by where the moon's shadow falls on the Earth's surface, and the moon's shadow just points away from the sun. The moon is traveling eastwards around the Earth at just over 2,000 miles per hour, and its shadow travels at basically the same speed, eastwards at just over 2,000 miles per hour. The Earth's surface is also moving to the east, but not nearly as quickly. The surface at the equator is only moving around 1,000 miles per hour, and slower the closer you get to the poles. Also, the parts of the Earth experiencing sunrise and sunset are moving mostly towards the moon or away from the moon rather than parallel to its motion, and so they're effectively moving 0 rather than 1,000 miles per hour. The point is, regardless of where you are on Earth, the moon's shadow easily outpaces the Earth's surface's eastward motion, which means eclipses appear to move from west to east. Put another way, the face of the Earth is about 8,000 miles across, so the moon and its shadow cross the Earth in around 3.5 hours, and less near the poles, while any point on the Earth takes 12 hours to cross the Earth. It takes half a day to rotate halfway around the Earth. It's kind of weird that the moon can orbit slower than the Earth rotates, but travel faster. But the moon has a long way to travel, nearly 1.5 million miles over its month-long orbit, which equates to around 2,000 miles per hour. In contrast, a point on the equator only travels 25,000 miles each day, which gives 1,000 miles per hour. There's no cosmic reason that eclipses on Earth travel west to east. It's essentially just a coincidence. If the Earth were twice as big or the moon were half as far away, then the length of a month or day wouldn't change, and neither would the direction of moonrise, but the relative linear speeds of the surface of the Earth and the moon would change, and eclipses might move from east to west. In fact, if the Earth and moon sizes were adjusted so that the moon was traveling slower than the Earth's surface at noon, but faster at other times of the day, it would be possible for an eclipse to move east, then west, then east again. Geometry is weird. Speaking of weird, those weird west-moving eclipses near the poles happen because the Earth's axis of rotation is tilted, so it's possible for the moon's shadow to be moving to the east, but hitting part of the Earth on the nighttime side of the planet. You can get a rough idea by opening up Google Earth and drawing a bunch of straight west to east arrows across the Earth to represent eclipse paths. If you look at these arrows from another vantage point, oops, suddenly the eclipse paths look way more wonky and some of them go backwards. And while we're in Google Earth, if you tilt the Earth like it is during the spring and fall and draw some horizontal lines, you can get a sense of why eclipse paths follow the curvy shapes they do, though actual eclipse paths are more complicated because the Earth is also rotating at the same time. In summary, even though the moon orbits to the east slower than the Earth rotates in the sense that a month is longer than a day, the moon also orbits to the east faster than the Earth in the sense that the moon is literally traveling through space at a faster eastward speed than the surface of the Earth. And that is what determines the direction of an eclipse. This video was supported in part by NASA's Heliophysics Education Activation Team, which loves solar eclipses. NASA HEAT's mission is to engage with learners of all ages like you and me, and to deepen our understanding of our closest star and its effects on Earth and the solar system. Solar eclipses are a great way to experience a different side of the sun than we normally do, like literally the corona extending out from its sides. If you ever have the opportunity to see a total eclipse, I highly recommend it. And NASA does too. Thanks to NASA HEAT for their support.